Now, the last type of bond I'm going to talk about is known as the metallic bond, which I think I know a little bit about because I was the lead singer of a metallic bond in high school. But I'll talk about that in future videos. But let's just take one of our metallic atoms here. So iron is a good example. Iron is maybe one of the most referred to metals. And so let's say we have a bunch of iron atoms. So Fe,
Music licensing
Fe,
reimagined.
Fe, Fe. Hope you can read that. These are all iron atoms. And if they're just atoms by themselves, they're going to be neutral. But when they are mushed together, they will form a metallic bond. Makes sense because they're metals. And what's interesting about metallic bonds, I'll draw it down here, is that metals like to share their electrons with the other metals. It kind of forms the sea of electrons. So what it can look like is each of the irons lose an electron. I'll draw it a little bit bigger. So let's say this is Fe plus. So it has a positive charge. Fe plus has a positive charge. Fe plus. These are all iron ions, you can imagine. Fe plus. And we're imagining that they have this positive charge because they've all contributed an electron to this sea of electrons. So you have an electron here, which has a negative charge. And electrons are not this big. So this is just so that you can see it. The electron here that has a negative charge. And so you can imagine these positive ions are attracted to the sea of negativity, the sea of negative electrons. Another way to think about it is that metals, when they bond in metallic bonds, they will have overlapping valence electrons. And those valence electrons are not fixed to just one of the atoms. They can move around. And this is what gives metals many of the characteristics we associate with metals. It conducts electricity because these electrons can move around quite easily. It makes them malleable. You can bend it easily. You can imagine these iron ions in this pudding or this sea of electrons. So you can bend it, it doesn't break. Well, if you were to take a bar of a salt right over here, and if you were to try to bend it, it's very rigid. It is going to break. So there we have it, the types of bonds. And it's important to realize that you can view it as something of a spectrum. At one end, you have things like ionic bonds, where one character swipes an electron from another character and says, hey, but now we're attracted to each other. And you get something like salt. Or you have covalent bonds, where we outright share electrons. And then you have things in between covalent bonds and ionic bonds, where the sharing is not so equal, and you get polar covalent bonds. And then another form, I guess you could say, of extreme sharing is the metallic bonds, where you just have this communal sea of electrons.